This meeting is being recorded.
Okay. So, okay, let's slowly start. The people are coming, but I think we can start. So now I'm going to share my screen first. First of all, welcome to our bootcamp, winter 2022. So usually we were doing this bootcamp 6 weeks, but this time we are going to do 4 weeks, but 2 sessions each week. So it's going to be 3 hours each day. And we added single cell analysis lately, single cell RNA-seq analysis. But what you're going to learn here, not only going to be about RNA-seq analysis or single cell RNA-seq analysis, you can use the things you learn here for other analysis too. Just make sure spend enough time for everything here. And then in the future, you're going to see that like doing analysis for ChIP-seq or ATAC-seq won't be that different. So the logic will be a little bit different, but you can adapt real fast after you finish this bootcamp. Okay, so we have like a couple of things that before we start, I want to tell. So in the bootcamp, I guess, I'll share my screen. Is it sharing? Okay. So we had this syllabus here. So you can see first week, we're going to do Linux environment. Today, we have Özkan. So Özkan will start the bootcamp. So he's going to show you how we're using Linux here in the cluster. So, and next week, we're going to continue with some genomic resources. And later, we're going to do RNA-seq data processing. So these 3 sessions, these sessions will be all about Linux, and we are going to run the commands from command line. So we are going to go into details here, and hopefully you're going to learn how we are using this Linux from command line, but it's not going to be easy. It's going to be painful, and you're going to see lots of problems while you're writing the commands when you don't use the right case, for example, when you're writing the command, or when you put when you don't put a space, for example, in between commands or some parameters. So we're going to talk about that. Then after the session, so we're going to work on Dolphin next. So in this interface, you're going to learn how to do some of those analysis using an interface. So you're going to submit your jobs using this interface to the cluster and process your data. And it's going to be much easier. But we want you to learn all these commands and doing everything from command line to understand like how we are processing data even in this interface. So we are going to do everything in the background, but still we want you to learn how we are doing this analysis, because in the future you might need to fix your problems yourself faster. So you might need to connect to the cluster. For example, your file is corrupted. You might need to copy that file back again from your backups. So we're going to talk about these kind of things. And then later we're going to talk about R. And again, we're going to show some R commands. You're going to be familiarized to R. So in like coming to this session, so it's going to be like around 2 weeks. So you have some time. If you want, you can go and check some R tutorials yourself to prepare yourself to those sessions. And you're going to understand and go faster when you come to these sessions, because these are hands-on training. So you're going to do those things by yourself in your laptop. And I'll tell you later, if you install R and RStudio into your computer, you can move faster. But there are other ways that I will show you here when we start learning R. We have R in our cluster, so you can connect and use RStudio in our cluster. So I'll show those kind of things too later. And then I'll show you the easy way of doing some differential expression analysis using the browser. This is also an interface that you can do many things with it without writing a single line of code. But again, we want you to learn R, and using R, you're going to be powerful and you can do many different plots. So that's why we want you to invest some time on it for your future, because you cannot do everything with any existing interface. So those are specific to some specific things, like the browser, for example, specialized for differential expression analysis. But if you want to do other things, you need to improve your R, and it's very powerful language. I think you should learn. And then later, in the last two sessions, we're going to do RNA-seq analysis, and Arthur is going to help here. And in Dolphin Next side, Onur will help us to explain how we are doing, creating new pipelines or running the pipelines, everything. So overall, it's like this. I think, and one more thing I want to show you. So we have this bootcamp. Everything is in our GitHub repository. So if you go to here, I'm going to paste this into the Slack, and I'll talk about Slack a little bit. So we have, we're going to put all the sessions here and the videos that you can follow up the sessions. And for example, Linux environment will be here, and the things about Linux.
But I think your screen is not visible. The Word document is what we're seeing.
Okay, sorry. Yeah, you're right. I need to reshare everything. You're right. Thank you. Okay, now, okay, so here, this is github.com UMS-biocore bootcamp. So I'm going to just put this into our Slack here, that you can go to that link. So how we are doing this Slack, how we are using the Slack channel, let me show this first. So there is like how to use the bootcamp Slack channel. So you can read this to understand how we are working with Slack. So basically it's like this. So you can say hello here, but when you ask your questions here on Slack, we will try to answer them here on Slack and solve your problems. When you have any error, on the side, when Özkan is talking, for example, you might have questions or you might have errors. You can write them here. And then how we are doing, like when you cover anything here, for example, this is my, I put this link here, or Kasturi write this hello team. So you can hover this and you'll see this reply in thread button here. So if you click here, so you're gonna see this hi Kasturi like this. So when I do this, oh, I didn't do right, sorry. I'm gonna delete this. I was trying to use the thread. Okay, here on the side. Sorry, I wasn't using this long time. So hi here. So see on the right side, I'm using this. Why we are doing this? Because see, it is grouped here, because sometimes we are talking a lot about one topic, and if you write this somewhere else, we lose it. So we cannot help you. So please try to answer your question here on the thread, then we can follow up better. And then that we finish all these things, we are using like emojis like this, 100% or something, to here, this emoji like this. When we finish that topic, when we answer that question, and if you're happy, just put an emoji here, and then we're gonna respond it and then move forward. And you can ask a new questions later. So please use like that, and then we will help you better. Other than that, so you can follow today's class. Yeah. Okay, so today's class here, and Özkan is gonna go over this. If you have questions, again, ask from Slack. If you think that it is important for everybody, like happened a second ago, so just ask your questions to Özkan. You can raise your hand in Zoom too, or ask your questions. Don't hesitate, please. Don't hesitate asking any questions. There is no dumb question, so you can ask anything. Okay, so now I think Özkan, you can start. Özkan is working for PMM, and he is going to help organizing all these bootcamps to us too in the future. Thanks, Özkan, for joining today.
Thanks, Alper. And just for clarification, if there's a question in Slack, and if Onur and you are thinking it's important, you can also interrupt and ask the question, and so everybody can hear it.
Özkan, may I add something? So if you don't have any Slack account, please write into chat or send an email, so I will add into our Slack channel, okay?
So my first question is the size of the fonts and everything okay for everyone, or I could make it a little larger if it's not visible. So
I can read.
okay. And if you click the link on the Slack channel, you'll end up here, and you are going to click session 1 and session 1 MD, and we're going to end up in this this page, which has everything we are going to do today. So this is not going to be hopefully a lecture type of thing. It's a workshop, more workshop like. So we are going to do things together, and if at any time, if you have questions, if you're having problems, you can ask me or ask in the Slack channel as well. So Alper nicely said that working in the Linux systems and in command line in the terminal can be painful. So the idea with these initial sessions is to make the process a little less painful. And hopefully at the end of this session, you are going to feel a bit more comfortable using the terminal. And there are a lot of terminology that's used sometimes also interchangeably. So we're going to make those nomenclature things a little bit clearer also. So the high performance clusters that we are going to use today, and most of the time we are using for bioinformatics data analysis, they all use Linux operating systems. And Linux operating system is just an operating system such as Microsoft Windows or Mac OS. And there are other ones that are less known. We are usually using these cluster systems not with a graphical user interface, but with a text-based interface that's called the terminal. And an operating system is actually just a layer of software that manages the computer's hardware and resources. So the computer is made up of several hardware pieces. So some of them are written here. The important ones are central processing unit, memory, hard disk, etc. And so when a programmer creates an application, a program, instead of communicating what the program wants to do directly to the hardware, the operating system provides a way to sort of provide a single interface that every programmer can interact with. Otherwise, we would have to know every hardware of every different computer, and you would have to write your code or software for specific hardware. So we all know Windows, we know Mac OS, but one of the most important operating systems is called Unix. And this was developed way earlier, way before than Windows or Mac OS. It's called Unix. And it's developed by a team in Bell Laboratories, AT&T, in the 60s by these two people, Ken Thompson and Dennis Ritchie. And of course, not just by these two people, they had a very good team, and they developed the operating system so they could, communicate what they want from this computer, mainframe computer here, and they used these terminals, and they had a keyboard, and they were typing what they wanted the computer to do, and their operating system Unix was translating that to the machine. And
sorry, I'm interrupting a little bit. So I am seeing only half of the screen. Is it is it how you want to show us, or is it a positioning? I mean, just half of the screen I'm seeing.
you mean this half is empty?
Yeah.
Yes.
Oh, okay, good.
Yeah. We are going to have a terminal here soon. So this is Unix, and then Unix became so popular that it kind of became the base for a lot of other operating systems. So people just took the principal components of Unix system, and then they added stuff on top of it. So examples are Mac OS, for example, all Linux software operating systems, these other ones that are listed here. So the most notable exception is Windows, which is not based on Unix, but otherwise they're all based on Unix, and they follow certain standards. So you can do the same things in all of these operating systems. And these are various Unix-based operating systems that are available today. So other than macOS, probably most people would recognize Ubuntu or Red Hat here, and there are less known ones. And the terminal it used to be this physical terminal that let computer programmers to type in what they want from the computer, their programs, it basically provides an interface to communicate with the computer, and it's based solely on text. So you are not going to have a screen showing you, several windows, and you can navigate with a mouse, click on this, click on that. It was obviously at that time it was not possible. And it turns out that even today, one of the most efficient ways of communicating with the computers are just using text. So today we use this software that's also called terminal, and we just type what we want from computer into this box. So I will just skip this picture for a second and go to the shell. There's also another piece of software that works within the terminal, and it's called a shell. And that basically takes in the text you are entering and interprets what it means for the computer. Right? So for most people, these are details that are not going to be necessary, but it's good to know. When there's something, somebody says, okay, this is a bash shell, for example, and this is a ZSH shell. You know that they are talking about the software that's running within the terminal. So this is the terminal, and I'm just going to start the terminal here so I'm right now running a Mac OS computer, and I will just start a terminal. So I will also ask everyone to start their terminal, and this is, if you are using Linux or Mac, you can just start the terminal from here. So Launchpad, you can start typing terminal, and then you should have a software coming up like this. I'm going to use something a little bit different, but essentially it's going to be the same. If you're a Windows user, it's a little more cumbersome, so you should have installed the PuTTY software. And you'll fire that up, and then we are going to connect to the cluster. But if you are using Mac or Linux, do not connect to the cluster yet, because I want to show a couple of things before. But if you're a Windows user, please go ahead and use these settings to connect to the UMass cluster. I'll start the terminal here. This is macOS terminal.
This is a little bit small, so maybe you can make it a little bigger.
Good.
Yeah, better, maybe, yeah.
And here I also started a virtual machine that's running Ubuntu Linux. And if you are on a Linux system, you can also use your start menu and then start typing terminal. And you are going to get this. So then we look at this. There are some similarities and some differences between these terminals. So we get a line that looks like this on the Mac OS, and this is using a ZSH or Z shell Unix shell. Okay, so as was mentioned here, so most Linux systems use Bash shell, born again shell, but macOS uses Z shell, for example. And since this is a Linux machine right now, on the right side, this is using a Bash shell. And the main difference here is this character we have at the end of the line. On the Bash shell, we have a $sign. On the Mac shell, we have a %sign. Their meanings are the same. This is what we call a prompt. A prompt means that the computer is ready to receive text input from you. So you can type, for example, hi, or whatever you want to write. And here it's the same. And we have a blinking box here and just a simple non-blinking box. This is the cursor, and this just shows us where so next time we hit a key on the keyboard, it's going to insert that character here on the cursor. That becomes important when we start typing things like who am I? Right, so let's say I mistype it and then I forgot I. So this is a text-based interface with the computer, and it's very different from the usual way that we use the computer, right? So when we're interfacing with the computer, I'm using here, for example, my mouse. I go here, for example, I select a different window. If I'm writing things, for example, if I see a typo here, I can click here and then start editing the text. Right? But on the terminal, things are a bit different. So I'm only going to be able to type things where this box is. And if I click on different parts here, so for example, I click between H and O, I hit A, but it still inserts the text here. So I think one of the most annoying parts for, when you start working with terminal is this. So you can't use your mouse to navigate. The way to navigate is with the arrows. Okay, on your keyboard, if you use the left arrow, you go to left, you go to right, and so on. Of course, there are a lot of shortcuts that makes this process very efficient as you use it more and more. But in the beginning, it's really hard. So I just move insert the A. And if I keep typing here, or if I try to go to the end using my mouse, it's not going to happen. Right? So I just use the arrow keys again. Okay, so and that's the prompt, that's the cursor. And here for the Linux users, this is the prompt, this is the cursor. And we have some other information here on the left side of the prompt. So at the beginning, you can ignore this. This is specific to my use case. But here we have idemo at bt something something and then a tilde sign. And here it's Özkan at Özkan dash virtualbox. So these are the usernames. The part before at is my username on my computer here. And here Özkan is my username on the virtual machine here. And after at, we have the computer's name. So this basically tells us who we are in this system and what's the computer we are on. And the third thing is here is the tilde sign, which is a shortcut for showing where in the operating system we are. It's shortcut for home directory. And it's the same here. It's maybe a little less visible.
By the way, can I tell what virtual machine is, or can you explain what virtual machine is? So Özkan is just using virtual machine to show you the Linux. So he can run a Linux machine on a Mac machine. So virtual machines are like that. So in the future, you might need to do such things. Just ask us. We can tell you how you can set up such things.
Yeah, this comes in very handy because several things that you might want to do on a bioinformatics analysis pipeline or most of the software, they only work on Linux. And luckily we have access to the cluster which runs on Linux, but some things may require a root or admin privilege, which you are not going to have on the cluster. So you might want to start a virtual machine, which you are the owner of, so you can do basically whatever you want. And also this is a safe way of doing things, because this is you can basically say, okay, this is the hard disk space I'm going to use for my virtual machine. And you may choose not to connect it to the internet, so it becomes sort of a sandbox to experiment with Linux. So this is my username and computer's name, username and computer name. Now we are going to actually, I'm just going to show a couple of commands, and if you are again on Linux or Mac OS, you can also replicate this on your terminals. So the first command is who am I? Right, so if I type who am I, and when we are giving these commands in the terminal, it only accepts it when we when we press the enter key, right? So before we enter we hit the enter key, we can do whatever we want here. It's not going to register, so it's you're free to do. But once you hit enter, there's basically no going back. So it's important to know what you've typed here is not something terrible, like removing or deleting all the files you have. So most of the time, you are not going to get a warning that says, oh, the command you entered is deleting everything you have. It sort of assumes that you know what you're doing. So I type who am I, enter, and then I get my username. Right. So one thing that you will notice here is that this line doesn't have the prompt, right? So because this is not the prompt, this is the output of my command. And if my command has an output or an error, it's going to print it on the terminal here, and it's not going to have the prompt sign. So when I get the prompt back, it means the machine is ready to accept more input. And if I type the same thing here, on this machine, my username is Özkan. And the second command is hostname. If I type hostname and hit enter, it gives me this name. And if I do it here, I will get this. So I will just give a few seconds so everybody can try these commands on their own computers. Then we are going to connect to the cluster.
Sorry to interrupt. Are we not using the space between the commands?
What do you mean?
The spaces between the commands, like you said, who am I? And there are no spaces.
Great question. So yes, so when we enter a command, it's like giving the computer a sentence, right? So each word needs to be separated by a space, otherwise it's not going to work. But in this case, who am I is a single command. So it's not like who is the first command and then am is the second and so on. So I want the computer to actually interpret this as a single word. So it doesn't have any space in it.
Okay, thank you.
Actually, I tried with the space.
Yeah.
And it gives me my username. Then it adds PTS/95 that I do not understand.
That's also a great point. And it brings me to an important point. So when we are giving the sentence in the terminal, the first word before the space, that's our command. The rest of the words we enter are arguments or options to that command. So when we do who am I, and if I hit enter here, the command is who, and am and I are arguments for this.
Oh, okay.
So depending on if the command who accepts or expects arguments, then it could take it, or it could ignore it if it doesn't expect anything, or it could say the command who doesn't take arguments, right? But if we just do who, then this is a separate command that doesn't tell us only the username, it gives more information, right? So it's the user and which software we are using right now, which processes. And yeah, I think we could also go there. For example, if I want to know if command who accepts arguments, I could look at its manual with the man command. So if I do man and say who, it shows me what arguments I can give it, right? So all the options and all other things that's possible to use with the who command.
And
Okay,
to exit, by the way, to exit from manual, you need to press Q button, like Q key in your keyboard. Otherwise, you're going to stuck there. Just to make sure to exit.
Yeah, exactly. So if I start this, so this is basically just one page of manual, and it turns out that this is all there is. So it's at the end, and so typically from if you want to exit from a screen, the command you use or the keystrokes that you would use would be Control and C. It doesn't work here. So here we just use the key Q on the keyboard for quit. So another maybe annoying part of using the terminal is you are not going to be able to use Control C and Control V for copying and pasting things. So for copying and pasting, so luckily there's also something that's helpful. So if you select something with double clicking with your mouse, it's automatically copied. And if you click, so you could do a right click and paste for pasting, or you could use the middle mouse button click to paste. But you are not going to be able to use Control C and Control V for these things. I'm not sure actually. Alper, do you know if you can use Command C and Command V for Macs?
No, yeah, you can. Command V would work. For
What about Command C?
Yeah, Command C also work for Mac, but not for PuTTY or other terminals. But for Mac, yes.
And when we connect to a Linux machine like the cluster, for example, is it still going to work?
Yeah, it is, I think, a terminal thing. You know, terminal allows copying and pasting on Mac machine, but not all terminals. I'm not sure, for example, your iTerminal will allow that, but Mac's terminal allow this. So there are other type of terminals too. You can go and check and download and install. Some terminals have more functionalities, some terminals don't. So you can find the best one you want. It's like, you know, applications, like terminal is also one of the applications there.
Yeah, so mine is working, but I tend to do a lot of tinkering with these things and change settings. So I didn't know if it's by default, if it's working, or if I did something at some point that made it possible to use Command C and Command V. Okay, so the next thing is to connect to actually before connecting, I also want to show that the terminal, as I said, it's just an interface to communicate or to explore or to do things in your computer, and it's not a Linux specific thing. So you could actually do something in your own computer. So if I do, for example, use list command, I will see, you know, whatever is in my home directory listed here. So it's basically very similar to using it with a graphical user interface. If I go to my home, so here the difference is I'm using my mouse and the Finder software, but you'll see that there are basically the same folders that are shown here are also shown here. But right now, what we're going to do is a little bit different. So we are going to connect to a different computer. And when we do ls there, it's not going to show my computer anymore. So we are going to be effectively working on a physically different computer at a different location. So let's go ahead and connect. So the command to connect to a remote computer, that the one that we are going to use here is secure shell SSH, and then I leave a space, and my username on the cluster is OA26W. So yours is probably going to be your initials, 2-digit number, and then W for Worcester campus, and at GHPCC06. So this is the number 06.umassrc.org. So what you type here is going to be only different here. Instead of OA26W, you are going to have your own username. And then hit enter. So I didn't get prompted for a password, but you are going to be asked for a password. So just type in or paste your password using right click and paste. Don't try Control V. And when you're entering your password, you are not going to get any feedback from from the prompt here. So normally when you're typing, you're going to see what you type, but obviously for password, it doesn't work that way. So, and you are not going to get those stars or asterisks as well.
I have a question.
Yeah.
First, when I hit ls, it gave me Galaxy. And then when I did SSH, my KB42W GHPCC, this is UMass RC, right?
But if you see Galaxy there, it means you already connected.
Oh, okay, okay. I connected from PUT.
Yeah, you are
So
already
that-
on the cluster. If you see
I see.
Galaxy or
Okay.
something, it's not, because that Galaxy directory is not belong to your own laptop. So it's in the cluster already. Okay.
Oh,
So-
okay, I see. So initially when I have connected to PuTTY using that SSH thing,
Yeah, then you don't need
okay.
to do that. Like Windows users are not going to use this SSH if they are using PuTTY.
Oh, okay, okay.
Now, maybe Özkan, you can tell the people how they can understand where they are using the hostname on the cluster, hostname command.
Right. Yeah. Yeah.
Yeah.
So that's what we're gonna do next. But before that, I want to show. I'm still working on the same terminal screen here, but my prompt changed. So the first difference here is, if you remember, this used to be a % because I was on a Mac Z shell. And now that I connected to a Linux computer, now I have a bash shell. So it has a $sign here. My username also has changed, and the computer that we are working on is also changed. Right? And if I type, and please go ahead and do the same on your terminals as well. If I do who am I, now I get my username that's on the cluster. And if I type host name, I get the GHPCC 06, which is the name of that computer.
Sorry to interrupt. I have a question here. So my screen on PuTTY shows me that the authenticity of the host, it cannot be established. And there is some RSA key, fingerprint, a big numbers and digits. And it says, are you sure you want to continue connecting?
Yes, so it's a security thing, but the address that we are using here is safe, so you can say go ahead and connect.
So should I write in command like yes or no?
Yes, yes.
Yeah.
Okay, thank you.
So I'll wait a few seconds for everyone to try this command as well, and make sure that you are on the cluster, so you will get your username when you type in who am I, and host name should turn out GHPCC 06. So if anyone has an unexpected outcome of these commands, then please either tell us here or on the Slack channel.
By the way, there's one more thing here. Notice to users thing. When you connect to the cluster, so there are explanations here about cluster and some news about cluster. For example, sometimes they're gonna shut down the cluster and they put a news about it here and the date. So when you connect to the cluster, just read these if there's something different than before, just to be aware of what are they gonna do in the cluster. So they just advertise things here for the Linux users, cluster users.
Yeah, thanks, Alpa. Yeah, this is actually important. So most of the time, at least I tend to just ignore most of the messages, but there are sometimes very important things. Here, for example, I knew about this, but if I didn't, there was an issue on the head node, and they needed to restart the system, right? So if we had anything that was going on here, that's right. So sometimes you start a process that goes on for days. If I had something that was running and they restarted the computer, that would have been interrupted. And if I didn't know you know, this interruption, I might have just get a partial result and just think that this was the result of my my analysis. So it's important to read these messages. Okay, so now going back to this picture here on the GitHub page, as we mentioned here, this is the welcome message, which is here, and we already talked about the prompt here, and you also see that this tilde is here, which means, so by default, when we connect to a computer, it brings you to the home directory on the computer. And directory is the same thing as folder, and on Linux and Unix systems, it's called directory. In everyday computers, you know, we call these folders. And so here also we can see commands and arguments, and we talked about this a little bit as well. So when we enter a sentence on the terminal and hit enter, the first word before the first space is the command, and the rest are all options and arguments. And so each word is separated by a space. That means if something is separated by space, if two things are separated by a space, they are considered two different things. That means that, for example, having spaces in file names and maybe commands and basically anything, having a space in the name is a really bad idea, because it's possible, but it becomes very error prone, because if you forget to take care of that, then you know your one word file name which has space will be interpreted as having two files which do not actually exist. And this is the terminal is also the space where the computer tells us, or the program tells us, if there's an error, it's going to print it here, or if there's an output, it's also going to print it here. For example, so these are all outputs. So the command is who am I? The output is my username. Command is hostname, and so on. So there was no error. But let's say I have a typo and then I forgot to type I at the end. Then I get an error here, which says who am, command not found, right? So then it's very important to read not only what we are typing and make sure that that's what we want from the program. It's also important to read what it's giving us if there's an error. It's most of the time very useful. So it tells you what the problem is, and then you can solve it. Sometimes, you know, you get an error that has something that's completely meaningless to you, but it pays to read it. Okay, I'm assuming that everybody has connected to cluster. And so we talked about the prompt already. On the cluster, we are going to have a dollar prompt. And on this page, everything that's in these gray boxes are representing the terminal. And if a text has a prompt in it, in front of it, it means that this is what we are supposed to type in next to the prompt. So, and a common error is just copying the entire thing and typing it here. So for example, if I copy $hostname and paste it here, the dollar command not found, right? So this is just to show you this is where we have the command, and when we don't have it, this is the expected output of the command. So now that we are on the cluster computer here, the Linux environment, we're going to explore it a little bit and see basic commands. And as starters, we could do echo command. So echo is if we want to print something, we use echo command. So if I want to print hello world, I would do echo and space hello space world, and then the output is going to be hello world. And next thing that I want to mention is Linux is case sensitive. So echo and echo are three different things. And if I wanted to use, if I use it with a capital like this, it would give me an error saying there is no such command as echo with a capital E. And also if I typed hello world only to print it here, it would give me an error that there is no command called hello. So I will wait a few seconds also for everyone to try out these commands, and you don't have to do hello world. You can, print out whatever you want, and maybe try different things and see what kind of errors you are getting. And if at any time you are stuck without a prompt, for example, if by mistake you start your command with a single or double quote, then enter, it doesn't give me an output and it doesn't give me a prompt, right? So now if I try to type other things, for example, exit, still gives me this greater sign and I can't do anything. So if you find yourself in this situation, you should use Control-C, and Control-C is shortcut for cancel, and it's going to take you out. So these are the basic commands that we are going to use, and simple things that we are going to do later in the session. But before that, we are going to talk a little bit about the directory structure, file system of the Linux computers or Unix. This is the file system represented as a tree. It's not very different from a typical file system. For example, if I'm using a graphical user interface like this, and if I go to my computer, so this is my hard disk, and these are the folders underneath, right? And this is the same for the Unix structure. And the hard disk, so to speak, or the base directory is called the root, and it's represented by a / character. And every directory has a specific name, as just like the folders in your computer. And folders, directories can have directories underneath them or files. And when we are referring to a file, file's location, we refer it to as its path. And the path has always a / between directory names and between directory and file names. So, for example, if I want to refer to the script.sh file anywhere in the command line in the terminal, I would use / because the first directory is this, and then home / /user1. And it's actually a mistake here. The documents, obviously the script sh is not in documents, right? So then we would have user1/script sh. So this is the path to this specific file. And this is called an absolute path. It's because we are starting from the beginning, from the root folder, and referring to this file. And wherever we are in the terminal, we can use this path to refer to this file. But sometimes it's, or most of the time, it's a little bit arduous and annoying to type this entire thing. For example, if you are working within a directory for certain certain analysis, you don't want to always say, okay, /home user1, and most of the time there are actually more layers. You just want to refer to it as script sh, right? So in terminal, in the command line, whenever we are referring to a file, if it doesn't start with a /, its path is considered to be relative to where you are. So if we are, for example, in the directory user, and if we just type script.sh, it's going to be the relative path to here, and it's going to be acceptable. For example, if you are in home directory, then if I want to refer to script.sh, I would do user1 /script.sh. Notice not that there is no / in front of this, right? So it's because it's relative to home. So this is important. It's somewhat not very intuitive, but as you use command line and the terminal more and more, you get used to it, and it becomes quite useful. Okay, so our next command is ls. The ls command is used for listing the contents of a directory or listing the information about a file. So if we do ls and then hit enter, it lists whatever is in our current directory. So I have all of these. So if you go ahead and type ls and enter, you are going to see what is available, which files, which folders are available in your home directory.
Is it okay if we only see Galaxy? Because the previous one, what I did, like user1 script.sh, it gave me like no such file or directory exists.
Yes, because you don't have those files in your home.
Okay.
Right? So yeah, that's a good way to look at it actually, right? So you typed user1 /script and it told you it's not it doesn't exist. So you can just do ls and see if really there's something user1, something called user1 or not, right? Maybe there is a user1 folder, but there's no script sh, so you would still get the same error. So ls without any arguments to it, it uses your current directory, which is your home directory, and it lists what's available. If you do ls /, what you should get is, because / is the root directory, what's at the base of this computer here, the root of GHPCC 06. So please go ahead and try this command as well. ls /, and you should get exactly the same thing as I get here. So before, you would get whatever is in your home directory, which may be different for everybody. But since we are working on the same computer, GHPCC 06, when we do ls / or root, we should all get exactly the same directories. Similarly,
That's not the case when I do it.
okay, what do you get?
So I'm getting bin, data, home, LSF, net, project, Silinex, TMP. I can
And-
share the screenshot if you like.
Sure, but this is also what we are getting here, right?
Wait, okay, probably I'm not seeing your screen correctly. Okay,
Is anybody else having a
Yeah,
problem?
perfect. So I can see your first line of the screen and not the complete cap. Okay, good. It's all good.
I'm not having a
I-
problem, but I do have a question. What is the significance of TMP being highlighted in green?
So this is just so maybe, okay, we'll see about this in a few minutes, but this is a long form list command. It gives you more information. And if I do that, this is green. Let's see why. So this is just a convention that's used in this system, and for each system it may be different. So the blues are for folders and green is for let's see, yeah, this has a T flag, so that's probably because of the Alpar. Do you know what the T flag does so that this becomes green?
No, it's not about T flag. It's TM. It's
It's
all.
executable.
Sorry.
No, it's writable by everybody. I think that's
No, when
that's-
you give the full rights like 777, it turns to red. Sorry, green.
Yeah.
Yeah.
So everybody can write to this, right? So that's
Everybody
why.
can write, exactly. But it's, yeah, but you're gonna show that later. So
Yeah.
Changing the rights of the folders. So that's gonna be important for the future.
Exactly. So for example, if you look at when I did ls on my home directory, there's this like lighter blue or aqua color, and then these gray ones, right? So I do it here with the long form. As I said, the blue ones are directories, and these white ones are files, and this light blue one is a link to a different folder. So it's a link to a folder at a different location, which is created here. So it's just showing that this is a link rather than an actual folder that's here. Okay, let's try all these other list commands as well. So if we do nearline or nl/nl, we are going to see, so there are different disk spaces for use in the cluster. One is called nearline, and it's located in the nl directory at the root. And for every PI who wants to have space here, they would have their own folder, right? But not everybody will have that. And there is also the project space. Okay, there are different properties of these disk spaces, which are not very relevant maybe at this point. So if we do ls/project, we're going to see much more. So most people have project space, but they don't have nearline space.
Can I ask something? When I did that ls-l, the one before this,
Mhm.
it said total 32, but it didn't give that whole list like that you have. It
Yes,
just,
the reason is that this is listing my home directory, right? So whatever is in my home directory, it's going for you, it's going to list whatever is in your home directory. So if you have just a single file, or if you may have nothing in your home directory, so then it
Well,
will.
it said total 32, but then it didn't list anything else.
Right. So the reason for that is the total means that the size, I believe, of the directory.
It just doesn't have like a, well, there's actually, no, I take that back. There is one listed, but it doesn't have multiple. So I was just not understanding the difference.
So the difference between what exactly?
So like you have those various, you have a number 536, and then you have all these things listed. And I have a number 32, and then I have just one thing listed. And on the very last thing, it says Galaxy.
Right. So I have more things on my home directory. So I have more things to list. And also the size is going to be more because I have more items in here. So you have a single item, and then the size of that directory is smaller.
Actually, it's not a size. Total there is, it's too much details, but total is the blocks in the hard drive, like how many blocks it's using this drive.
Oh, I see. And then what
the
does
block-
Galaxy mean?
Galaxy is just a directory that, so that directory is going to be mounted into another machine that to transfer some files from this machine to another. We were using Galaxy, but it's just old now, so we are not using that anymore. So just, keep it there for now, but in the future, we're gonna remove those directories. But again, this total here is the number of blocks that directory is using. Okay.
But I mean, I never did anything to put this Galaxy in, so that's why I was a little bit confused too. So I didn't know what.
No, it's default, like it's default directory. It was already there.
Okay.
Yeah, so it's default, and it's maybe a good point to introduce the permissions as well. So in Linux systems, each file has a permission associated with them that are listed here, and we are going to go into detail later about the permissions. But you are only allowed to create a file in wherever you have permission to do so. And the regular users, they have permission to write into their home directories only. And maybe if your group has a project space, for example, then you would have access to that. And admins of the system has access to everywhere. So they can actually put things in your directories, but you cannot put new files, for example, in some other directory where you don't have access to. So this makes it easier for admins to control the system, and makes it harder for users to do some things that they're not supposed to do. So, okay, so we've all done these lists, I think, and there are some files in this directory, I believe, that we are going to use. So it's good to look at that as well. So in this directory, we have several files, and so again here, a different color scheme comes up. But here the greens mean something else, actually. The greens mean that these are executable files. So the colors are a little bit also context dependent. So if we do, for example, a long list, then we're going to see that the permissions on these are not actually 777, which was for the green directories. But when a file is green, it means this is an executable file. It's going to have an X flag here.
By the way, when we say 777, you're gonna learn what that means it's using like a kind of a way of changing the permissions of a file for the user, for the root, for the group, using these letters here, R, W, X, R. So you're gonna learn that at the end of this class today. So just when we say 777 means like giving the whole rights. So it means that, like, when a director, a file has like RWX, RWX, RWX in a whole, like filled that RWX, it means that 777. So it's like, we use these a lot. That's why sometimes we forget to tell what they are. But you're going to learn this today and how to change it. Please learn that, because in the future, you're going to realize that some people are going to share a file with you, and they're not going to give the read rights, for example, and then you cannot look at that file. So, and then you're going to ask, could you please give that read permission to the group, to your group, for example, in your lab. So you're going to learn those things today. By the way, in 10 minutes, let's take a break. Like after maybe when you started locating applications and software packages, so we can do a 10 minutes break and then continue after that, okay?
Okay, so let's go until the modular system and then take a break.
Yeah, okay, perfect.
So we've seen what's in the class folder here. There are these files. It's a little bit more than what we have here. Okay, so the software and applications are, there are conventions in a Linux system where we have software. So these are the directories that are listed here. But it could be different depending on what the system admins decided to do. So you can always change all these things. So when we do, for example, use command ls, the computer actually looks at all of these places in a certain order and tries to find a file that's named ls. So this is a command, but this is also a program that somebody wrote, and we put it in one of these locations, and the computer search these locations and finds it. And if I want to know what actually is what the computer is using when I type ls, there's a command for that as well, which is which. So if I say which ls, it's going to show me which file is ls. So it's /bin ls. So it's the first place that's actually searched. And that also means if I could do /bin ls instead of just ls, it would give me the same outcome as ls. It's a little bit different because as it's shown here, it uses this command with certain options, right? So when I do ls, it's using this command bin ls with color equals auto. So this determines what the colors of different types of things are. If I just use the plain command ls, that as it was written, it's not going to color anything. If I give it options to color, it's going to give us the color version. And this is showing the use of which command for a different command diff. So if we do here which diff, we are going to see where diff is. And in case of diff, the default use here, it doesn't use any options. So it's exactly the same as using this file path and diff. for ls it was different. For ls it was using some options when we just use ls.
Sorry, very short, quick question.
Sure.
What is diff itself? What does it do?
Diff, so if we have, for example, diff is for comparing two files, if they're different and what's the difference, right?
Okay.
So
Thank you.
if I, so let's say, I quickly just demonstrate this. So I just created two files. So one is just says A and B. So I didn't create what I wanted actually, but B has A and B and C, right? So if I say diff AB, it tells me the first file has A and B, but the second file doesn't have it. And the first file doesn't have A and B and C, and the second file does have it. So it becomes handy, for example, if you have two large files that may differ. For example, there are 2 million lines in each, and they differ only in one line, right? Instead of looking, what's different line by line and opening in a graphical interface, you could just use diff, and it's going to just show you what's different between them.
Thank you.
Okay, so before we start the modular system of the cluster, let's take a 10-minute break, and let's start again at 10:30.
Okay, great. See you at 10:30. Yeah, I think we can start, huh, Özkan?
Yes.
Yeah, maybe you can switch the gears a little bit to go a little faster.
Okay, so the cluster uses a modular software system, which allows it to install a lot of different programs and different versions of the same program at the same time. It just doesn't load it for each user at all times. So when you want to use a certain software, you would need to load it. So, for example, let's say you are going to use star aligner for RNA the sequencing alignment. So if I do this, so you would run it with the command star, and if I run it, it is available for me. But if you want to run that, the same command, you should go ahead and try. You should not be able to see anything because it's not loaded for you. The way to look for modules, these softwares are called modules on the cluster, is to type module avail for the available modules. So if I hit enter, waits a little bit, looking for what's available, and it just spits out everything that's available. And it's a lot, as you can see. And I see that there are 6 versions of star here. And if you don't want to look for what's just look for star here, you could also do avail and the first 3 letters, for example, and then it would only give you the modules that are available that has this in it, in their names. So if you, for example, know that you want to load a certain version
Question.
of star, yes.
So this is not block sensitive, letter sensitive.
It is.
Okay, so
Yeah.
when you search for module star, you wrote everything in caps.
Yes. So yeah, I understand the confusion. It's because the software itself, it uses the command with capital letters, but the way it's installed on the cluster uses, as seen here, is all lowercase, right? So
Okay.
if I did, for example, again, capitals, it's not going to find anything.
I see.
So the convention is usually, it's for star, it's the exception, and for some of these things like NAMD and BMD here, the convention is to use all lowercase letters for almost anything you do on command line, just to avoid this confusion. Right. So, but you can't really control what everybody does, and maybe there's a good reason why the author of the star software did that. But that's just the way it is. So if we want to load, for example, star version 2.70e, you could either just copy this or just type exactly what it is. We would do module space load space paste the exact module name, and now it has loaded it for our use. So if you do this, if you load the star module and then type star, you should get this exact screen here, which shows you how to use star, because star expected some arguments such as a reference genome and FASTQ files and so on. Just shows a helpful message. And if we do, for example, which star, and it shows us exactly where it was loaded. And this is the same information that we got here, that when we loaded the module, it put the software here. Right? So it's the same location, and in that location, there is a software in the bin directory. So once you are done, you don't have to unload the software, but for example, you want to use the star version 2.5. Right, and in that case, you really have to unload the module that you loaded and load the specific one you want. And somewhat of a nice feature here is you could do module unload. Don't have to type in the exact version like we did for loading. You could just do module unload star, and it's going to unload that. And we've already shown the module avail, which shows everything that's available. And if you just start typing, a few characters that's in the software name that you are looking for, things become much easier. You will get less or a smaller list, basically. And the next command that we are going to look at is pwd, which is short for print working directory. So if we do pwd, prints the directory we are currently on. And we already knew it from here. It was the home directory. And for me, if I, the absolute path to my home directory is this /home/OA26W. And yours is going to be /home/your username. And so the location is very important in the Linux system. So because we are going to refer to many things in relative path, not absolute path like here. So if I'm here and I do ls, for example, it's going to list what's in my current directory. And if I want to refer to this file, I can just type singularity.conf. I don't have to do /home/OA26W/singularity.conf. But if I'm not here, if I am, let's say, on the, let's not do that. Maybe in a minute. So the next command is cd, which is short for change directory. So that's just for moving around in the file system. So if we do, for example, cd // as you might remember, is for the root directory, and it brings us to the root of the system. You can already see the change here, so it shows us that we are at the root. And if I do an ls here, it's going to show me what's at the root folder. There are some nice shortcuts that's employed by the cd command. So if you use cd without any arguments to it, it's going to bring you back to your home directory. And cd tilde is going to also bring you to your home directory, right? So tilde is short for your home directory. But this is obviously a bit unnecessary here, because if you use cd without any argument, it's already going to do going to bring you to your home directory. And cd, so there are two location shortcuts as well. One dot means your current directory, and two dots mean your parent directory, which is the directory your current directory is within. And as I mentioned also, the tilde is the home directory. And one thing that's one mistake that's common is to use cd dot or cd single dot without leaving a space between them. And that's obviously going to lead to an error, right? So if I do cd dot, there's no such command. But if I cd space dot dot, then it's going to bring me one folder up. And if I do cd single dot, it's not going to do anything because it brings you to your current directory, which you are already in. Another shortcut is cd dash, which brings you to your previous directory, which is my home directory. Right. So if I do this, I expect to go to home. Or in this case, I was already here. So, and then I used the cd dot command and I changed the directory to the same directory. So if I want to go back, it's still bringing me to this directory. But if, let's say, I'm back to my home directory with cd, cd dot dot, go one level up, and then cd slash dash, and then I'm back in my own home directory. And this we already went through. When a file path begins with a slash, it means it's an absolute path. We are describing the path from the root directory, so it has the full path, and you can use that path regardless of where you are in the system. So if I am here in home directory, and if I use, for example, bin. So if I want to look at what's in the bin directory in the root, I could do this, and I could go one level up and run the same command. Brings me the same result. Although I was in different locations when running this command because I used the absolute path to the bin directory in the root folder, I get the same result. But if I go to the root directory, right, now I will use the relative path of the bin, which is in this directory. If I do ls, I see bin here. I can use the relative without starting with slash. I will see what's in bin. But if I'm in my home directory, I do this, I get a different result. So this is now showing me the bin directory, which is present in my home directory, which you probably don't have. Okay, so please go ahead and run these commands in this order to get a feel of what they are doing. So one way of navigating in the file system is using the cd command. For example, if I'm going to work in this specific folder directory for a long time, I could change my directory to there. And then after this, I can just refer to everything that's in this without using the full path, right? So I could just refer to these files as their own files. But let's say I want to work on my home directory, but I want to look at this data file that's in this folder. Okay, so I don't want to go to that directory because I don't want to work there. So I want, for example, I want to save my output in my home directory for whatever reason. If I want to reach this file from my home, I will use the home, the whole path, the full path, or the absolute path, right? So if I want to, for example, look at that file, full path to the file is this.
Can I ask a question?
Yeah.
So after the fourth one, CD double dot, the first
Right.
CD double dot, I see that command not found. Is it because I went back to my home directory and I cannot change that directory?
It's likely
I mean-
that you forgot the space between the CD and two dots.
Okay.
By the way, if you use up arrow, you can see what commands you run before in your history. So it's gonna be handy, when you're running the same long commands in the future, you can press that button up and down just to go back and forward.
Yeah, exactly. And since we have to type everything and the case is important, the typos are important, we have to write exactly what is necessary. There are some nice tools that helps with that. One of them is called tab completion. So for example, let's say I want to list things that are in this directory, right? And it's not always the case that I have a text here that I can copy and paste. Sometimes you have to start typing, right? So then we do ls space. I know where that it's in the project directory, so /pr. And then if I hit tab key on my keyboard, it's going to complete what is available in this system until we have different alternatives, right? So if after PR I hit tab and it types O, which means there's pro, and then maybe there's like programs and project and various different things. If I hit tab twice, it shows me what's available, right? So there's proc and project. Then I type J, and now it can't be proc anymore. If I hit tab again, it completes until you have another option or the directory is finished. All right, let's say then, where was it? UMW biocore, right? So I say UMW B, and then I hit tab. So when I hit tab once, it doesn't do anything because there are multiple choices. If I hit it twice, then it gives me all the options, right? Then I do I. And now if I hit tab, it's going to complete the biocore, right? So this is a nice way of typing quickly and without errors. And even if I don't know what is available here, I could still do tab twice, and without me typing anything, it shows me whatever is available in this folder. And I see that class, then I can start typing CL, tab complete, and enter, right? So then it gives me this full command and its output. Okay, so we've already explored the ls command to some extent. And now it's maybe a good time to talk about options to commands. So the options to commands, so options are arguments that start with a dash or two dashes, and it allows you to pass options or what you want specifically from a command. So for example, for ls, if we do ls-a, again without forgetting the space between, so -a, it uses the -a option for ls command, which means show all. So, and it's different from regular ls without the A option. What's different between the two is if we want to show all, it also shows the so-called hidden files, the files that start with a dot in front of their names for various purposes, various system files and things that are not necessarily used all the time by users. These files are named with a dot in the beginning of the name, and they are not going to show with the regular list command. Right? But if you want to see everything, you do ls-a. Another option is L. So if you do L, it shows in the long form. So my ls shows me in this form. ls-l is going to show me long form with each file on a single line and a lot of information on these files, right? Like the permissions of the file, how many links point to this file, and the owner of the file, which is me for all these files, and the group that the file belongs to, or the file belongs to, and the size of the file, and when it was last updated, and the name of the file. So it's a very detailed list. And you can combine different options as well. So if we do ls-lh, it's the same as doing ls-l and space -h. H is for human readable. So as you see, these file sizes are in bytes here. But if we do LH, it's going to show us in kilobytes, and for larger files, especially, it becomes problematic because if you have a number that's 10 million here, it's sometimes hard to just understand how big the file is. So another nice command to explore in a more graphical way is tree. So the tree command shows you everything that's available in your target directory, or if you do it without any argument, it's going to work on your current directory. I'm just going to show you how it works for my home directory. It's a little bit useless if you have too many things. It's just going to run and run. And this is a nice demonstration also of when to use the command Control-C to cancel. Because right now I'm just typing on my keyboard, but it's obviously not doing anything. So I could do Control-C, and it stops printing all those stuff, and then it gives me back the prompt. So one thing to be aware of is, so when it was printing out everything and it was not accepting my input, it's actually keeping that in memory. So if you type something and hit enter and wait until the printing finishes, it's going to carry out your command. So just to be something to be aware of. And so many of the commands that they have options, right? And tree is one of them. And if you give it the option D, it doesn't list the files like these. It just lists the directories, right? So it will stop listing at CPP here, and it's not going to give us all the other stuff, right? But it's still going to print a lot, for me at least. So another option to D is number of levels you want to print. So if I don't want to see, every detail, I could give it a capital L and then space, and then I can give it what level I want to print. So if I do 2, for example, just going to go. So one level is the original, the folders in my home directory, and then the second level is the folders within them, and then it's not going to go into the next level. So if you want to just get a picture of how your work environment is looking like, you can use the again this capital L and followed by a number, right? So how many levels you want to do. And so I talked about tab completion, but I forgot to reiterate what Alper said, using up arrow to go to the through the history of your commands that you use. So most of the time it becomes very useful. Instead of typing this entire thing again, if you know that you used just a few commands ago, you could just use up and down arrows to find out what you used, if you want to reuse it or if you change it a little bit. So the man command we've seen in the beginning to look at. I don't know. I don't remember which command it was, but maybe it was ls again. But if you want to see the manual or usage of any command in the command line, especially if it's part of the system, a manual is available by typing man and then space and then your command line. So ls, you will see a brief intro and how it's used. So you would use ls space. When these are in brackets, it means these are optional. So you could use ls without options. And then you can provide a file or not, because these are also brackets. So I can use ls, I can use ls space option, and I can use ls space option and then follow it by a file or directory path. And there's a nice description of everything that's available here, for example, -a, or so most options have a single letter.
Watching this, I really cannot see anything here. Yeah, it's so small, the size.
What is this?
You are doing the sequencing bootcamp? Yeah. If I put it on the large monitor, there is no, well, I cannot hear anything. So so I cannot see this thing.
So you can't see the screen? Or you can't read because the fonts are too small?
Maybe you can make it larger a little bit. Maybe the people cannot see because their monitors are small. You can just press like Command plus to make it larger. Might work.
Is this better?
Yeah, Command plus, and then you can narrow the, yeah, but the size of the font will be larger. Okay, cool.
Okay, so is it better for people who couldn't see before? Is it enough? Okay. So the options, there are two types of options, the short form and long form. Short form is with 1 dash and 1 letter. Long forms are 2 dashes and a longer name. And they mean the same thing here. So if it's -a, it just explains what it is here. So do not ignore the entries starting with dot, the hidden files. And capital A, it has a different option. So it lists the hidden files, but it doesn't show the current file and the parent file, current folder and parent folder shortcuts, right? And all these other options. So maybe another thing to look at is L that we've been using. L is the long list format, and you can combine all of these options together and they would work. And it's also shown here. So you could do ls-a space -l, or you could do -al or la. They all should turn out the same result. So copy this. And I use my up arrow, left arrow to navigate, and delete these, and just do -al, gives us the same thing. LA, the same thing. Or, for example, I want to do --all. So it's all the same, just different ways of doing the same thing.
I started typing what you were typing, and it says log file, and then it's got a whole bunch of letters after it. I don't know. I had like, I didn't have the cursor when I started typing, so I don't know how to.
I think you have to quit
How do
the
I?
manual.
Oh,
Q.
yeah. So the manual, you're going to quit with Q.
Just hit Q.
Yes.
Oh, and then enter, or just Q?
No, just Q.
Yeah, it's just typing it. It says log file, and there's a whole bunch of letters after it. Can I go backspace those, delete those?
You can just.
I do have a cursor now.
You have a cursor?
Yeah, but it says log file.
Just delete those. Just delete with the delete button. You can delete.
Yep, and then hit Q.
No, I think you need to do Control-C first, and then you are going to hit Q.
Okay. All right, thank you.
Okay. Yeah. So when in trouble, try Control-C, and it helps most of the time.
How do you get out again if you have something that says end and you can't do anything else?
Q.
Just Q?
Yes, just Q.
Capital or little?
No, just hit the Q in your keyboard.
Okay.
Okay, so this is just mentioning what we've experienced just a moment ago. When I typed 3, it started printing all those things. So if you are seeing, just sometimes it's a typo, sometimes it's some unexpected thing. If you're seeing an stream of output, you can't do anything, just Control-C. And sometimes you might need to do it several times, but eventually it stops. So then we can try the list directories on our class folder, -d /project. And it just shows the directories, right? No files. I didn't use it would show all the files. Next command is creating a directory. For this, you need to go to your home directory with CD if you are not there already. Because of the permission things that we mentioned briefly, you are not going to be able to create a new directory in the class folder, for example. So you need to go to your home directory with CD. And the directory creation command is mkdir or makedir. So there, and then whatever name you want to give to your folder, and Bootcamp, enter, and if you type ls, then you should see the Bootcamp folder here. Please go ahead and do that. And if you have any trouble, please let me know.
Do we want us to type in the mkdir?
Yes, yes. So you are going to create a bootcamp folder in your home directory with this command mkdir space bootcamp. And since we created this in our current directory,
I don't see anything saying bootcamp in there.
so you've done this, make their bootcamp,
Mhm.
and
So
then
it says permission denied.
yes, it's probably because you are not in your home directory. So you don't have permission to create a folder in other places.
Oops.
So first we do CD,
Okay.
and you'll see that you are in home by looking at this tilde. If you don't see tilde, you are not at home.
I'm at home now.
Okay, then if you do that, it should create.
Yeah, when you're following these instructions in this material, so you should start from the beginning. In this case, for example, creating a directory starts with CD. CD will take you into your home, and then when you create, you will be able to create because you have rights in your home. This is your home.
It just says Bootcamp and Galaxy. Is that fine?
Yeah, that's fine. Yeah. So you remember you had only the Galaxy before, and now you created a second folder called Bootcamp, right? So now you have two folders in your home directory.
Mine says command not found.
And then what does it say? What command is not found?
NKDIR.
That's
not possible.
That's not possible. it must say something. Maybe you forgot the space and it's like.
I guess she said NK. It's going to be MK.
MK?
Yes, MK, dear. It's
Make
make
directory.
Okay. Yeah. I heard MK.
Make directory. Make directory. It's a short version of make directory.
Is it okay that I can see only bootcamp in blue? Is it right,
Yes,
or
it's okay.
did I miss something?
No.
You created bootcamp folder. That may be the only thing that's available in your home directory.
Okay.
Oh yeah, mine is good now.
Okay, great. And now that we created this folder and with ls, we see it. And now we can just change our directory to that bootcamp by typing cd. And since this is in our current working directory, we don't need to start typing /home/OA and full path. We could just simply type bootcamp and hit enter. So here already I see that I am in bootcamp directory, but to be sure, in working directory, and it gives me the full path to where I'm working right now, which is /home/OA26W, which is the same as my home directory, and /bootcamp.
Oh.
So does anyone have a problem so far? Is everybody in their bootcamp directory and they have it showing here on the left side of the prompt? If so, we can just move on to the next thing. So the next thing is to go to another directory using the full path of the class directory. Right. Please go ahead and do that. CD/, and please try to use the tab completion because it's super helpful and it's important to get used to using that. So I am in the class folder already, where I can see this. Print the working directory. I see exactly where I want it to go. It's the same as, yeah.
Then what do we do? TWD?
Yeah, you can do PWD and confirm that you have arrived at where you wanted to go. And now we want to go back to the bootcamp directory in our home directory that we just created a moment ago. So there are many ways of doing that. First is, and maybe the easiest, if you know that you were just there, you could do cd space dash, right? Or you can use the full path to the directory, which is for me, cd /home /OA 6w bootcamp. Alternatively, as you remember, tilde is shortcut for home, and then / bootcamp. They are all going to bring me to the bootcamp directory in my home. So please try at least one of those and do a print working directory and see that you have actually arrived at the bootcamp directory in your home directory. I do / dash and back in class, up arrow, back in bootcamp. So this is just if we try to create this directory again by this, for example, make there / bootcamp. Since this directory is already there, it's going to tell us what the error is. It cannot create directory, file exists. Another interesting thing with the make directory command is if you want to create, for example, a nested directory which has 3 directories, right? So if a bootcamp, let's see what the example here is. Yeah, so if I want to create bootcamp dir 1, dir 2, dir 3, so this is like one directory within bootcamp, and then the second directory within that, and the third directory within that. It's not going to allow us because makedir by default only creates one directory, and if the path so far until here is not already there, it cannot create this one, right? So at this point we have only bootcamp directory, and we can only do a one level creation, right? So please go ahead and try creating this nested directory. Now the error is maybe not very intuitive, right? So you are trying to create something and it tells you there is no such file or directory, which is trying to say actually, so since you are trying to just create this specific directory in the structure, the parent directory, it doesn't exist, so it cannot do that. But with the -p option or I guess parents, right? So if you pass this option, it's going to create first this and this and then this. So let's try that as well. So since I just ran this, instead of trying to copy paste or type the same thing again, I use the up arrow left arrow, go all the way here, -P, and don't forget to leave a space and enter. So now I expect to see a dir1 in my current directory, which is the bootcamp, as I can see here. And within that dir1, I want to see dir2 directory, and within that I will see it. Or I could just use the command 3 and see. So my current directory, it has dir1, that has dir2, that has dir2. Or another way of doing that is, instead of not passing any option to tree, which uses the current directory, I can pass the bootcamp path, and it's going to show me the same thing, which is what's in bootcamp directory. So I'll give a few seconds again, so everybody can do these commands and see how it's working in their hands. Okay, so the next thing is copying files. Copying file is achieved by the command cp, short for copy. And the way it works is you have cp, then space, and the file you want to copy, and the destination. Destination can be, if it's a folder that exists, then it copies this file to inside of this folder. If this is not an existing path, it's just going to copy this file, and then the new name or new path for that file is going to be exactly this. And you can also have, if the last argument to CP is an existing directory, you can have multiple files before. So you can have CP, file 1, file 2, file 3, and then finally an existing directory. All those files are going to be copied to your last
question.
Yes.
Is it possible that after making that -p tilde bootcamp dir 1, 2, 3, it says 0 files, 0 directory, 0 files? Maybe I haven't given bootcamp.
This?
Oh, okay. Yeah, I missed bootcamp. Sorry. Yeah, I just gave mkdir -p/dir 1, 2, 3.
Okay, and you are not, you're not going to be able to do that. Okay, so copying. So let's go ahead and copy this funcs.r file, which is which exists in the class directory, by providing the absolute path to the file, and then this is our destination, and see what happens.
So you want us to write that all out?
Yeah, I mean, you could copy and paste from here. You can type it out, but if you're typing, make sure you're using tab completion so there are no typos and it doesn't take too long.
I can't copy from what you're doing.
You can copy from here. Do you have this page open on your computer?
I what? Do you have what?
So yeah, you should have this page, the GitHub page from Slack channel.
I'm just my Slack doesn't run on my computer at work. That's why I wanted to do it at home, but my home computer isn't letting me access the class.
Okay, yeah. So that's then quite hard, because you have to see it from my share.
Yeah.
And then type it on your own. Yeah, then you have to type it.
But
What's
that
after
GitHub
project?
repository, sorry, that GitHub repository is accessible from anywhere in the world. So you can just go to that HTTPS github.com ums-biocore bootcamp, and you can click the session 1, and then you can come to this page from any computer.
Not from Slack though?
No, you don't. Slack has the link. You can click the link on the Slack, but you can open your browser and write this https://github.com ums-biocore bootcamp by hand, and then you're gonna have this page in your computer.
So I will just type share
Can you
this
put it in the chat?
It's already put in the chat. You can just
Yeah. No, I've been typing everything. I haven't been, because I don't have the Slack.
Yeah. So I put it. Okay. So Samuel also shared it.
Samuel put it into the chat. Cool.
It's in the chat.
Yeah. You just click that, and then it should open up the same page.
Oh, here it is. Oh, once you know that. Oh, that's gonna take a while. I'll just finish typing it. What does it say after project?
This is okay.
CP project.
But we don't have much time, Özkan, so maybe you should move, because they're gonna have the homework, and
the homework is supposed to be finished in the session.
No, but they need to know enough to be able to do their homework. Like at least they need to know like how to pack the files, zip the files, and those kind of things. That's why. Can you do a little bit faster?
Yeah, sure. I just don't want people to be left behind. Maybe then questions can go to Slack, and we could move a little bit faster here.
Yep.
For people who has access to Slack. So I just copy this, and then just copying again the next comments that are provided here, which is going to show us the information on the file, the first file that we copied, and then second, the destination file. So the size of the file is exactly the same, 5532. But some other information is different, like who is the owner of this file, right? And the name of the file is also different. It was funcs_r, and now it's called first. The permissions also are kept, and yeah, this is the stuff we talked about already. So this was copying a file. If you want to copy a directory, let's look at the bootcamp directory with the tree command again, like how it looks. It's like this. Okay, so was there something that created a directory called first that we missed? Oh, yeah, here. All right, I made a mistake. I didn't create this folder first. So now the bootcamp/first is a file for me. So I will just correct that, and hopefully you followed this and you have a directory called first and second in your bootcamp folder. So hopefully yours, your tree command looks like this now also.
I only have first. I
Uh,
don't have something that says second.
so if you copied this, yes. So you've probably followed my instructions before, and didn't create these folders, right? So that's my mistake. And if you have done that, please follow these commands. So make sure that you are on Bootcamp and type in RM space first. And after that, copy this make their line from the GitHub page.
That one. After RM first, copy MK directory, make directory.
No, so just
Okay,
the RM.
I think Özkan, like what after you show the deleting files, you know, the people can follow up all these from scratch. So just continue showing other things, because you know there are other things that we need to show today, just fixing individual
Yes,
errors.
but I'm not going to be able to do this copying directories part. If
It's fine. I think, you know, everything is written here, so you can skip some parts, and then we need to show how to zip the files and remove the files. That's why please go a little faster, because we don't have too much time now. We only have 30 minutes. The people can follow these things themselves later. Okay.
all right. So let's
I don't think I can actually. I didn't even know about signing up with the Git thing, and you're aware I can't do the problem here, but.
Okay, but everything is written here. If you follow all the steps here, you should be able to recreate everything. Everything is written here. And
I was just doing that, and it didn't have the second. I went in, I opened up the GitHub, and I'm copying, pasting, and I only have first.
Okay, Hala, let's do this in another time with you, okay? Because this class should finish what we have now, and we can solve your problems later. Is that fine?
Sure.
Cool.
Okay, so we are picking up from here. So the tree command, it shows a similar thing to here. And when we are copying the directory, the first directory into second, we're going to have to use the -R option to do a recursive copy. Otherwise, directories are not copied by default by the copy command. So now, if I do tree bootcamp again, the structure has changed. I now copied the first folder with the funcs R file in it into the second folder. Next thing is to removing a file and deleting it, which uses the RM command. And so you can either go to the directory a file exists in and then remove it, or you can provide the full path to a file to remove it. So let's just follow whatever is written here. We go to the first folder, list the contents, and we see the funcs R and RM funcs R. And if I hit enter, that file is gone forever, right? So there is no trash. There's no way to retrieve that file again. So when you're using RM, you need to be really careful. For removing a directory which is empty, we use rmdir command. So we're going to again follow the code here. We're going to go to the second folder. The list, there's the first folder which we just emptied. And here I can do rm dir first. And if I do another list, the folder is now empty. Look at tree structure. Second folder doesn't have the first folder or the funcs.r file in it anymore. And the rm dir is only for empty directories. If you want to remove a directory with the contents, you still use the rm, just like you're removing a file. You need to use the r flag or option. So F is for forced deletion. So it's usually it's not a good idea to do that. But since these are not very important files, we could just go ahead and do it. So if you do rmrf, it basically says delete this, whatever the consequences. Sometimes, you know, it could ask you for important files, for protected files. Are you sure you want to delete this if you don't have the F flag? But if you are sure already, you could use this entire command. And you can see that the first folder here was not empty, but we still deleted that. So it's not that anymore. If we do to Bootcamp, the first folder, which was just here a moment ago, is no longer here. Moving a directory or file, and this is the same as renaming. It uses MV for move, and you will have the target, so whatever you want to move, and the destination where you want to move it. So if I want to move the directory 1 to second, I do that. We do tree structure again. V1 is now in second, right? So it moved the entire thing. So the next thing is to move this directory to dir 1 instead of keeping this in dir 2. So one way of doing that is we could change our directory to dir 2 and then move this directory to its parent directory. So here, if you look at it, you see that dir 2 is here. And move dir 3. If you remember, 2 dots means the parent. So the parent is dir 2. So but that wouldn't make any sense, right? So this is already in the dir 2. So if we want to move it to 1 level up, we would do / and then the parent of that. So that. Now we have moved this to here into there again. No, it moved it into second actually. Yeah, because we moved it to directory above. Sorry about that. Okay, so as anything else, you can use relative paths as well as absolute paths. Absolute paths will work wherever you are, whereas relative paths will work if you get the correct relative path to a file. Okay, so renaming, as I said, it's uses the exact same command, move. So we are going to change directory to Bootcamp again. And now there's only the folder second. Hold on a second. Yeah. There's on the second, and then we're going to move second to, so basically rename this directory second and rename it first by using move second first. Now this directory is named first. So moving on to files, every file is a binary file, but there is a convention of grouping files into two categories: text files, which you can open and read, and binary files that you cannot open, but you need specific programs to read them. Redirecting standard output to a file.
By the way, like till this point, like if you had any errors, any problems, so if you want to start from scratch, what you can do, you learn how to remove the directories with the content. So you can run that rm-rf ~bootcamp to delete that folder. And then you can go to the top and then repeat all those things again. And please try this a couple of times to understand all the directory structure, like moving around the files, moving the files like from this location to another, or directories from this location to another. So this is very important concept that you need to understand, because in the future, when you're organizing your files, like RNA-seq files or output files, usually we use these kind of commands a lot. So that's why at the beginning, it's going to be painful to understand, like, all dots, like tildes, slashes, spaces, everything will be hard. But then when you do this a couple of times, it's going to be like routine, like it's going to be so easy for you. But you need to do this a couple of times. That's why please do your homework too. And it's going to teach you everything here. Okay.
So far what we've seen is the output of the commands. If there's an output, it was printed here. But it's also possible to write these into a file. It's called the redirection. And this is, we achieved this by using greater sign. So that, but we are already at the bootcamp, so that's not necessary. So the tree first, the command, it outputs this. If we do the redirection sign, the greater sign, and then provide a file name, we don't get any output printed here. Instead, now if we do ls, there is a file called my3.txt. And so if you want to see what's inside this, use cat command. My3 text, and it shows us basically the same output, but now it's in a file. And this is another example. We do ls-l and send it to, instead of printing in the terminal, send it to a file. And with the cat command, again, see the contents of that file. So this would be what would we see, what we would see exactly if we didn't redirect the output. So text files are important because most files are, if they're not compressed or if they're not specified, there are text files, and you can read them, you can look at them. And let's just do this again. Bootcamp, and there's the my3 text file. We can use, so we used cat command here for reading what's in this file. Another command to use is less. The difference is less shows one page at a time, so it's going to show us the first page of the file, and then we can do page down or down arrow to see. So for example, if you have a large file, cat would show the entire file and you would basically just see the end of it because it would create a huge stream. You do less, it goes page by page. And here again, we see this end notation. So if I do Control C here, it's not going to work. Again, I use the key Q to exit from less. More is basically the same, but more is less used because it's an older and less featured program or command. Another useful command is head command, and you can provide how many lines from the beginning of a file you want to read. And here, for example, we want to see the first 5 lines of this file. So these are the first 5 lines in the file funcs are in this directory. And if I want to see the last 5, then I would use tail and give these options. And this is the last 5 lines. Even if the lines are empty, they count as lines. So the last 2 lines are empty here. And cat, as we've seen, shows what's the content, but it's going to show the entire thing. Right? So if I want to see what's in the beginning, I would have to go all the way up here. Whereas if I used less here, I would see the beginning, and then I could use my arrow to see what's in the rest of the file. Creating empty file, this is a largely maybe unnecessary thing, but you can use touch command. And if you just paste this, it creates the file. And it creates the file only if this file doesn't exist. If this file exists, all it does is it changes the timestamp of the file. And the second file and list the contents, and we see these 2 files. Okay, so these are again permissions for each of these files. So symbolic links are very useful in Linux systems. It makes sort of shortcuts to files in different locations, and the system treats as if that file is actually there. So if follow the commands here, this command means make a symbolic link to this file, and where to create that link is dot, which means the current directory. So if I list now, I have this different looking file here, functions, funcs are, and it shows me that this is actually a link to the file that's actually located in here. Right? But I can now access this file by just using its relative path here. So I can do less, and it works. Before creating this, I had to use either the full path, or I would have to go to this directory and then use the relative path to the file. Now a little bit more about the permissions. So for each file, you will have 10 columns if you do a long form list command. And the first column shows whether this is a directory or a link or a file. And the second three.
Sorry.
Yeah.
One short question. When you say column, what are you referring to? Are you referring to RWX as everyone as one column?
Yeah, exactly.
Okay, sorry.
Yeah. So the next three are permissions for the owner of the file or the user, which is myself here. And whoever created the file usually is the owner of the file. So the next three is for the group of that user. So user group here is again myself. And the last three are for everybody else who has access to this computer, right? So the cluster, so basically everybody in UMass. And everybody gets three permission characters. And as I said, the first three are user and group and others. The first is the read permission, which means that whoever has this permission can see the contents of this file. The second is the write permission. So if you have the permission, you have the letter here. If you don't have the permission, you will have a dash. The second one is write permission, which means you can change this file, which includes also deleting. The last one is execute privilege and execute permission, which only applies to executable files. And if a file is an executable, such as this file here, then whether this user, the owner, is allowed to execute the file, if the group members are allowed to execute, and so on. And usually only the owner of the file or the admins of the system can change the permissions of a given file or directory.
I have question. So
Yes,
when I comment this one, I saw the region, some region is blinking. It's the blinking, like the project UMW biocore class function R is kind of blanking, like
blanking. I'm not sure what you mean. So you ran this and what happened?
Right. And then I followed then the line of the after total, then the second line in the function R after that it's kind of blinking with the black heart. So
that means that you did not run this exactly as it is here. It means this is a broken. Is it red?
Function R is red, and then
so it
the
means
rest is
a broken link. So if you try to link, so if this file doesn't exist, that is going to be red and blinking. So you probably didn't run this. So maybe there's a typo or something. That if that link is broken, then it's going to be red and blinking.
I see.
You can remove that wrong broken link with the same command rm space funcs.r, and then it will remove it, and then you can run exactly that command, link command again to create the right one. So yeah.
Okay.
So we went through the permissions, and if you want to change the permissions, as I said, either you must be the owner of the file, or you must be the admin in the system. So chmod is the command for changing the permissions. And then it's followed by the change you want to make, and finally the file you want the change on. For example, if you want to change, so if you look at this my file text, so the last 3 bits here, the others, so everyone else have read permission, but they don't have write permission, right? So I'm not sure what this is. Maybe this is, yeah. So this is, we could do this. It's not going to change anything because others already have read permission. We can just go ahead and do that. So it didn't actually change anything, right? If I'm not mistaken. But let's say I want to also give others write permission, right? So then I can say others equal read, write, execute. If I do this, it's going to give them write permission and execute permission. Yeah. So since I made this executable or execute permission, this became green. And others now have write and execute permissions here. And another way of doing that is, for example, if I want to give the group write permission, a different way of doing that may be group plus write. Then it would give the group write permission. Instead of giving exact things, you could add or remove permissions with plus or minus. Right now, the group also have write permission, for example. So for many things, you can use wildcards or asterisk sign, and that means all the characters, basically. And another kind of wildcard is question mark. It just asterisk means any character and as many times as possible. So for example, if you say asterisk.txt, everything that is ending with txt would be included. But if you use question marks, then there has to be exactly this many characters, right? So we just want to test this. Directory, tier 1, and if I do this, everything that has any character, any number of characters, but ends with .txt, which are these 3 files or 4 files here, will be copied. I'm not sure if this is correct. Yeah, so you normally wouldn't need dot. So if you just have dir 1, it should also work. So it's basically just copying these files to dir 1 directory. And if you look at 3, for example, now we have all the text files copied in here. So this is a nice shortcut of copying everything that has some common things in their name instead of doing one by one. So file compression and uncompressing the compressed files is achieved or can be achieved by tar command. So following the instructions here again, the tar command, the options to the command start with dash. C means create. So we are going to create a tar pack, and V is for verbose, so some details, and F means create this file. And after that, we can list whatever file we want to be packed. We want to be packed in this file. So because we used the V flag, it told us what it did. And or if we just do LSL, we created this packed tar file, and now it includes first folder as well as the my text tree file. But this is just packing multiple things into one file. It doesn't compress. If you want to compress, you add the Z flag. And again, give it a final file name and whatever you want to include here in the zipped file. Now, if you look at the zipped file, its contents should be the same, or even it has one more file compared to the packed tar. But since it's compressed, this file is much smaller. Its size is much smaller than the unpacked file. We're going to create a new directory and unpack and uncompress these zipped files here. So for uncompressing, so when creating a file, we were using C for create, and for extracting a file or files or an archive, we're using X flag. If the file is zipped, you also want to unzip it, obviously, and then you need the Z flag as well. And again, we use the verbose flag, and it just creates an output of what it created. And listing what we have here. The archive is still there, but now we have the contents of the archive extracted.
I think, Özkan, that's perfect. Yeah. Thank you very much. I think we should stop because it's almost 12 here. So you should do the rest by yourself. Not many things, I think, remain. Thank you, Özkan, to almost finished. I'm going to go over these things on Thursday. And please learn how to remove files, but make sure you're removing the right thing, because when you remove your files or directories, when they go, they go. So you cannot get them back. So learn like before you press that enter button after you write your remove command, make sure that you are removing the right files. So, and after you remove, for example, Bootcamp directory, you can do everything from scratch. So again, like do this a couple of times before you come and learn as much as you can and come with your questions. You might have questions that you cannot find yourself. You cannot find the answers yourself. So I'm going to answer on Thursday. And thank you for joining this class today. Thanks, Özkan, for giving all these comments.
Yeah, my pleasure.
And hopefully we're going to talk again on Thursday. We're going to meet on Thursday. Okay, thank you very much.
Also, Alper, yeah. Guys, please join the Slack channel. If you have an invitation by either me, Onur, or Alper, and you can ask questions there. You don't have to wait until Thursday, as just Alper said, but let's just use Slack. It's much better to answer and ask questions there for sure.
Exactly. Like when you're listening, you know, if you ask your questions on the back end, we can answer them faster there. So, and then, because we are recording all these things. Yep.
So the Zoom recording will be available in GitHub page, right?
Right. I'm going to put it there, all this Zoom recording. And yeah, please send your questions. Anything is not clear.
Where do we get the homework?
Homework is there in the same GitHub page. So at the bottom of that page, there's a homework. So do your homework before you come on Thursday, then you can follow easier everything on Thursday, especially next week. You know, we're gonna run RNA-seq analysis using command line programs. So please do your homeworks before you come next week, and also before Thursday. You're gonna follow faster. And yeah, other things, if you have other questions, please send us email, come with your questions, and we can arrange other time with a couple of you. If you couldn't solve, we will help you to to learn. And I know it's painful, so don't worry. Like, you know, first time when I started, it was the same, like nothing changed. It's very painful to start with, but you'll see, like, you know, after you do this couple times, it's gonna be much easier, and you will not remember these painful times. Okay, and good luck. Hope to talk to you on Thursday.
Thank you. Thank
Bye,
you
guys.
very much. Have a nice day. Bye.
Bye.